Hello. Welcome to Snowfall Predictions for the Northern and Southern Hemispheres. In recent years, climate change is becoming more obvious than ever. The United States has experienced many changes and increased extreme events such as hurricanes, drought, impacts on agricultural practices, rapidly receding sea ice, and rising sea levels, just to name a few. So, how is climate change altering the snowfall activity around the world? We analyzed weather data from 6 ski resorts, 3 resorts in the northern hemisphere and 3 in the southern hemisphere to learn what resort experienced the most total snowfall since 1990, which resort had the most powder days, which are defined as days that experience more than 6 inches of snowfall, which month for each resort had the least snowfall, which month for each resort had the most snowfall, and snowfall trends to help us understand what we can expect of years to come, as well as a fun tool to help predict if it's snowing in your area based on 2 features: temperature and humidity percentage. For coding, we use Jupyter Notebook, Python, Pandas, SQL Alchemy, scikit-learn, Path, and Pickle. For storage and analysis, we use PostgreSQL, pgadmin, and for visualization, we use Tableau, Python, and HTML. The resorts we chose to analyze in the southern hemisphere are Craigieburn Valley in New Zealand, Tivendale in South Africa, and Val Nevado in Chile. In the northern hemisphere, we looked at Furano in Japan, Zermatt in Switzerland, and Timberline right here in Oregon. The starting columns were date time ISO, city name, temp min, temp max, humidity, snow 1 hour, weather main, and weather description. Of those columns, we decided the columns of importance to our analysis were date time, temp min, temp max, humidity, and snow 1 hour. The columns deemed unimportant to our analysis were dropped. Our data was presented as a row for each hour of each day. This made our data harder to understand, so the decision was made to resample the data. To do this, we used resample and performed aggregates on the remaining columns. For temp min, temp max, temp, and humidity, we used mean, and for snow 1 hour, we used sum. Finally, we set our resampled date time column as the index and changed the name snow 1 hour to snowfall.
Export CSV to SQL. After cleaning all 6 CSV files need to be exported into Postgres database using DB string to connect to Postgres. Created a database engine to connect to Postgres using the DB string, then push CSV files to Postgres shows the amount of data. So using the ERD with relationship diagram is a flowchart that highlights different tables and their relationship to each other. Using our final ERD as a guide, we'll create 6 tables, one for each CSV. SQL helps calculate retrieving specific information from databases, easy with analysis. Creating tables will help answer questions. Some of our questions are max snowfall per year, average snowfall per year, and snowfall greater than 0. Other queries are max and min POW days over 6 or under 6 inches. Using the count and extract clause to return data after grouping by year, setting the max greater than 6 and the min less than 6, doing for both tables. Some additional queries: snowfall per month, max month snowfall. We extracted year from date and month from date, and some snowfall to total snowfall, grouped by month and order by ascending. Same thing for max month snowfall, having the sum less than 0. Having the same for max month snowfall, but having the sum more than 0 ordered by total snowfall. And doing the same thing for the min-month snowfall and snowfall per month. On our graphs here, we have snowfall per year and POW days 6 inches per year. So separating the countries by northern and southern hemispheres to show snowfall trends throughout the year. southern countries have the least amount of snowfall per year, except for Val Nevada, with the highest snowfall in 1997. Tiffindale shows little to no snowfall throughout 1991 through 2021. Southern countries have more snowfall per year, where Timberline have the highest in 2021. The northern countries have more powder days per year than southern countries, highest powder days in the northern hemisphere in Timberline at 100 inches back in 2021. The highest powder day in the southern hemisphere is Val Nevada at 50 back in 1997. Tiffindale shows no signs of improvement. The total snowfall since 1990 as inches shows that Timberline has snows about 20,000 and then Tiffindale around 1,500. Deepest snowfall in a single day per year shows that Zermatt has the deepest snowfall in a single day was 2012, about 115 inches in the northern hemisphere, and Val Nevada deepest snowfall in a single day was 2022 at 96 inches in the southern hemisphere. So we're looking at here snowfall by weeks and snowfall per month. The weeks of the year corresponds to the months where the best time of the year to hit the slopes. For northern, the best time would be weeks 2 to 11 and 50 to 53. For the southern, weeks is 23 to 38. The hemispheres are opposite seasons. Northern hemispheres tend to pack more snowfall compared to the southern hemispheres during the months of December and January to be the peak for northern hemispheres, where southern hemisphere peaks time are July and June. The hemispheres show the change in seasons where snowfall is best for shredding the mountain.
For our first instance of machine learning, we decided to go the route of using random forests to try and predict whether it would snow or not. We decided to use only humidity and temperature for this model, while also changing the snowfall columns into zeros and ones, with 1 being where it did snow and 0 where it didn't. With our random forest test, we were able to hash out over 17,000 predictions. Out of those, it was able to correctly predict over 15,000 times. This gave us an accuracy score of over 86%, which is a great score to have when trying to predict whether it'll snow or not. In terms of precision, our model predicted it to not snow over 14,000 times. Since it correctly predicted nearly 13,000 times, this led to a precision of 91%. However, when trying to predict if it would snow, our model predicted it to snow nearly 3,800 times. Since it correctly predicted about 2,500 of those, our precision dropped to 67%. Oddly enough, our sensitivity results were nearly identical to our precision. Our sensitivity for not snowing was also 91%, and our sensitivity for snowing was once again 67%. Our next instance of machine learning was using linear regression to try and be able to see if we could find a relationship between total snowfall and each passing year. When looking at the northern hemisphere, each of the 3 ski resorts had a positive slope when it came to snowfall per year. This in turn meant that as the years went on, there was a larger amount of snowfall. Each year amounted to about 8 inches more of snow per year. However, in terms of the southern hemisphere, 2 of the 3 ski resorts had a negative relationship, with Tiffindale being the odd man out. Each year amounted to losing 2 inches of snow per year. When combining all 6 ski resorts, it ended up coming to a positive relationship, with each year gaining about 3 inches or more of snowfall than the previous one. With this out of the way, I'm going to give the floor to Caed once again, so he can talk about that Flask app we created. Take it away, Caed.
Thank you, Trevor. Well, here's our Flask app. We're going to play with it a little bit. So this is based on our random forest classifier, and we can tell whether it's snowing in your area based on temperature and percentage of humidity. So let's start with 34 degrees and 99% humidity. It is snowing. Let's change that humidity to 95% humidity. It is not snowing. All right, now let's change that temperature to 21 degrees. It is snowing. Finally, let's go up to 72 degrees. It is not snowing. So you can see based on what you know about weather and snow, The results are pretty accurate. We actually had an accuracy score of 86%, which is pretty good for weather. So here we go. This is our visualizations. They are completely interactive. As you can see, they have tooltips that pop up. I love these graphs here because they show the contrast between northern and southern hemispheres. Southern hemisphere is on the bottom. But all these graphs are completely interactive. You're able to select specific portions of the data and analyze them how you so choose. And they're also color-coded so that you can easily skip to the highest day for the year. And that is our Flask app. Fun little interactive tool.
Thanks, Caed. When starting this project, all three of us predicted that there would be less snowfall per year now than there was back then. To our surprise, we found it quite the opposite, with more snowfall now than 30 years ago, at least with these 6 ski resorts. Something we could have done differently was not taking as many columns out during our planning process. When trying to create visualizations, we found that we may have taken out too much data and limited ourselves with what we could visualize. We were still able to establish what we initially set out to do, but we may have been able to do so much more if we gave ourselves slightly more to work with. Finally, we would like to thank Open Weather for providing us with the data in order to do our project. We all agree that this was the best choice to move forward with, as it gave us nearly everything we were looking for.